Hello, and welcome to this particular session where I'm going to, this is kind of a supplemental section, and I'm going to work some of the homework assignment problems for you. In fact, I'm going to work three of them. Problem 5.1 will be the first one I work, and apparently this might be part of a multi-problem set where he's giving you some data to start with and then maybe asking more than one questions about that data. But let's read the question. A theft avoidance locking system has a first cost of $20,500, an annual operating cost of $1,400, and no salvage value after its 3-year life. Assume that you were told the service provider by this asset would be needed for the service provided by this asset would be needed for 5 years. So this thing only lasts 3 years. So we're going to have a second cycle of it, okay, to get us to year 5 or through year 5. This means that the asset will have to be repurchased and kept for 2 more years, okay? What would be its market value, call it M, what would it have to be? That's market value is kind of a salvage value after 2 years in order to make this annual worth the same as it is for the 3-year life cycle at an interest rate of 10%. Determine the market value M using factors. Well, we're going to use the app or whatever. Like I said, I always use the app. So let's draw up the cash flow diagram. The asset cost $20,500 now, so we'll draw that $20,500 as a present value. Okay, I'll say P equals 20,500, knowing that that's a negative number because it's a cost. And then its annual operating cost, AOC, is equal to 14,000 a year. So that's going to happen for the 3 years of the life, 1, 2, and 3. 14,000. And if all you needed was 3 years of service, that would be the end of it. However, and it does not give any market value or salvage value at the end of year 3. This no salvage value, it says. Okay. But now the author says you need to rebuy it, okay, to start years 4 and 5, okay, 4 and 5. And of course your operating costs will still be $1,400 a year, but when you rebuy the asset, that's an extra $20,500 at the beginning of year 4, but it's the same as the end of year 3, so it's placed right here in time, at time 3. So now he wants to know what the salvage value, call it M, must be, that's the question mark, in order for the 5-year cost, annualized, to be the same as the 3-year cost. So let's start by calculating the 3-year cost. That is, I'm going to circle just the first cycle of this. Remember, this goes with the second cycle. These two $1,400 go with the second cycle, 14,000, and that salvage value, M, goes with the second cycle. That's the second year of the second cycle, okay? So I'm going to calculate this value first, okay? So I'm going to say the annual worth of years 1 through 3 at 10% is equal to, and this is pretty straightforward, you got a present value of 20,500 and then you have an annual series. So this will be 20,500 A given P, I'm annualizing that 10% for 3 years, plus $1,400, knowing that all of these numbers are negative. So if you actually, I should go ahead and put them in there as negatives. All of these are negative. The M is not going to be negative. So that's a negative, and that is a negative. So that's going to give me the number minus $22,243 if you do the calculations using the app. Okay, if you use the tables, it could be a few dollars off because the tables don't carry as many decimal places as the app does. So now what I'm going to do is set the entire 5-year cost equal to the 3-year cost. That's what he wants, and then solve that equation for M. So I'm going to say annual worth for years 1 through 5 at the rate of 10% will be equal to, well, now I'm going to take this 20,000 and just spread it over the entire 5 years. Okay, so that's minus 20,000 A given P, 10% for 5 years. And then I'm going to have this uniform series of minus 14,000, and that's already a uniform series, so I'll say minus 14,000. And then I will have this value here, which I want to make it an A series over this period of time. So what I have to do is first bring this value here back to the present time. That will be P given F. Then I'll spread it over the 5 years. So that'll be minus 20,500 A given P, 10% for 5 years. I forgot the P given F. P given F, 10% for 3 years. So that was the step of bringing this back. This step here, that's a P. P given F. This is a future value. That's the present value. That's 3 years in between. Then I'm going to multiply that. This is a present value now, times A given P, 10%, 5 years. Then there's only one thing left, and that's the M. Okay? And that's a future value at the end of year 5, so that'll be plus M, A given F, 10% for 5 years. Now basically I'm going to set this equation equal to the minus 22,243 and solve that equation for M. Okay, so let me go ahead and do that. I'm going to set, well, I'm just going to set this equal to, well, I'll set the two of those equal to one another. So we'll have the following. If you compute this, let's do this annual worth of 1 through 5 at 10%, and if you spread this 20,500 over 5 years at 10%, you get minus 5,408. And then if you you take this number here, bring it back to the present, and spread it out. When you bring it back to the, well, let me put the minus 14,000 here. And then I'm going to do this calculation first. So when you do this, P given F, 10% for 3 years, this will be minus 15,000 and $402. So that's what this number is, this product here. And then I'm going to take that and spread it A given P. That's a present value now, 10% for 5 years. And then I'll have this M plus M, A given F, 10% for 5 years. And I'm going to set all of this equal to 22,243. So, and then solve that for the M value. Okay, so I will have the following. I'm going to move this over a little bit. Minus 5,408 minus 14,000 minus the product of this and this is 4,063. And then I'll have the M times A given F, 10% for 5 periods, and I'm going to set that equal to minus 22,243. Now, when I solve this for M, I'm going to get basically add all of these to the other side of the equation. And when I add these numbers to both sides of the equation, I'll get M times A given P, 10% for 5 periods, equals, this will turn out to be $1,228. And so now if I solve this equation for M, I can multiply through by P given A, because P given A is a reciprocal of A given P, and I'll get M equals 1,228 times P given A, 10 and 5. And when I do that, I will get M equals 7,492. This is, I made one mistake. This is F given A. This is A given F, and so this is going to have to be F given A. And when I do that, I'll get that value. So I got the number 7492. The answer key actually got 7492. The answer key got 7494. And the reason for that is they're using the tables in the back of the book, and I'm using the app. The app is a little more accurate, but again, your answer only has to be within 2% to be correct, graded correct by the Connect system, and certainly that's going to be well within 2%, okay? So that's problem number 1, and I'm going to go on and do the next problem is going to be problem number 3. Assume you won a worldwide lottery that pays 1.4 million in year 0. 5 million in year 1, and 200,000 in years 8 through 100. Assuming that 100 years is as long as infinity, really I don't do that because there's not any difference between 100 years and infinity. For all practical purposes, it would be very, very little difference. Calculate the perpetual annual worth for years 1 through infinity at an interest rate of 7% per year. And use dollars, not millions. Okay, so let's draw the cash flow diagram first of what we're going to win here, okay? And so we'll start here, and at time 0, that's year 0, you win 1.4 million, or $1,400,000. And at year 1, you receive another $5 million. And then years 2 and 3 and so on up to year 8, 7, 8. There's no receipts in years, additional receipts in years 1 through 7, but in year 8 you start receiving a uniform annual series of $200,000 per year, and that goes on year 8, 9, and that continues on to year 100. So that's a uniform series. And then he wants you to spread the whole thing out as an A series as n approaches infinity. So what we need to do, we learned in the previous chapter some concept called capitalized cost. And if you recall, the capitalized cost was the present worth of an infinite uniform series. And you got that because you can get that, the capitalized cost as a function of I, was the present worth of an infinite A series. So you have this A series and you get P given A at rate I as n goes to infinity. And we showed that this quantity here, this the algebra, if you take the limit as n goes to infinity, that's equal to 1 over I. So it would be A times 1 over I. Well, in this problem, we're doing the opposite. We're going to get the present worth of your lottery winnings, and then we're going to make them into an infinite A series. So if you solve the equation, this is a present worth. If you solve it for A, then A is equal to P times I if n goes to infinity. So that is going to be the equation basically that I'm going to use, but I have to get the present worth of all this cash flow first. So let's work on it. P is equal to 1.4 million, or 1,400,000, plus this is at time 1. So that's a point in the future. I need to bring it back to the present 1 year. So that's going to be 5 million times P given F. The rate is 7%, and it's for 1 year. Now I have this uniform series sitting out here of $200,000. So that's an A series. That's dollars per year. And so that's going to be plus 200. And I want to find its value back here. Well, if I multiply this series times P given A, I will get a value 1 year before the year that the series starts. So I'll get a value there if I get P given A. So let's do that. P given A, 7%. Now, how many of them are there? They go from 8 to 100. So there's one for every one of the years from 1 to 100 except the first 7 years. So there's 93 of them. Once I multiply this times this, I get a value. This value right here is right here in time, okay? And now this is a present value relative to this series, but it's a future value relative to time 0. So I need to bring it all the way back. So I'm going to do P given F 7% for 7 years. Once I do that, I'm going to have the total present value. If I go ahead and work on this, I get this 1.4 million, or 1,400,000. This number here is going to be 1.07 to the minus 1 times 5,000, which is 5,4,677,887. And then the first thing I'll do is calculate this quantity to get me the present value at time 7 of that whole series. And that number turns out to be, I'll put this in a bracket here, $2,857,143. Now I have to bring that back 7 years because it's not at time 0. That'll be P given F, 7%, 7 years. And when I do that multiplication, I'll get 1,400,000 here plus 4,677,887 plus this product here, which is $1,779,285. And when I sum those up, they're all positive numbers. That's $7,857,182. And now I want to spread this out over an infinite time period. So I say A is equal to P times A given P, I, N. This will be times 7,857,182 times A given P, 7%. As N goes to infinity, this whole quantity is just I. So this is going to be 7,857,182 times 0.07. That's the interest rate, which gives me $550,003. Now this is the answer I got. The author really wanted you to just assume that series went to infinity, and if you did that, you got an answer of 549,653. They're off by about $350. That is a very small percentage of nearly 8 million, and so, or 550,000, either way you want to look at it. And so this is close enough. This is the actual accurate answer. That one, the answer key is close enough. Either one will give you the answer. The next question I'll do is number 5.7. Problem 5.7 says a company that manufactures magnetic flow meters expects to undertake a project that will have the cash flow estimated below. So here's the first cost is minus $830,000. The equipment replacement cost in year 2 is $300,000. So they're either going to have to replace some or all of this system for another $300,000 at the end of year 2. The annual operating cost for the entire time is $880,000 per year. And finally, the salvage value is plus $250,000. These are all negative. They're all cost. The life is 4 years at an interest rate of 10% per year. What is the equivalent annual cost of the project? So it wants a uniform series that represents the annual cost of this cash flow. Let's draw up the cash flow as we always do. So we've got basically 4 years here. I'll go 1, 2, 3, 4. The initial cost is $830,000, so we'll put that here. That's a single cost. Then I'm going to put this next because that's a uniform series. That's $880,000 a year for the entire 4 years. That's dollars per year. Then we have at time 2, so I've counted for that now. Then I have at time 2 a minus $300,000, so that gets added here at time 2. And that's a single cash flow. And then we have the salvage value of plus, these are all minuses by the way. And then we have this plus $250,000 at time 4. And we want to get the annual equivalent over the 4 years of that cash flow. So I'll say A at 10% equals, I'll start with this and I'll spread it over 4 years. So I'll get minus 830,000 times A given P, 10% for 4 years. Then I have a uniform series of 880,000, so I'll just put that there. Then I have this maintenance or cash flow at time 2 of 300,000, which I need to bring it back to the present time and then spread it over the 4 years. Or I could take it out to the future and spread it back, but I'm going to take it to the present. So this will be minus 300,000 P given F, 10% for 2 years. That gives me a present sum here. Then I want to spread it just like I did this present sum. That will be A given P, 10% for 4 years. And then the last thing I have is that salvage value, and that's a plus. That's the only plus in the calculations. 250, that's a future value relative to the 4 years, so that will be A given F, 10% for 4 years. So when I do some of these calculations, I'll get A at 10%. The minus 830 times A given P gives me minus $261,841. Minus 880 is an A series, so it just is added in. And then the next thing I do is take this 300,000 back to the present. That's this multiplication here. When I do that, I get minus $247,934, and then I need to spread that number back over the 4 years. So that's A given P, 10 and 4, and then this multiplication, the plus 250 times A given F, is to spread this 250 back over these years, only it'll be the plus side, so that becomes plus $53,868. And so I have one more multiplication in here to do, and then I just add them all up. This is minus 261,841 minus 880,000. This becomes, when I spread it out over the 4 years at 10%, 78,216, and then I add this plus 53,000. All of these are dollars per year for years 1 through 4. And when I sum these up, I get the total annual equivalent at 10% is minus $1,166,189. And so that gives me the final answer. The author's final answer is very close to that. It turns out to be very close, 1,666,184. So it's $5 difference. This is, again, because I use the app, he used the tables. And so that is the end of this particular problem session. Good luck with the homework assignment. Thank you.